expectation of independent random variable. So if x and y are independent random variable, then the expectation of their product is the product of expectation. So we are going to prove that. First, expectation of xy is the same as we write a function f on xy. This function f is basically the product. Now, using the definition of expectation of function of random variable. So if we see xy as one random variable, then this is saying that we take the function of this xy pair and then multiply the corresponding probability of p of this xy pair, sum over the sample space of xy. The function f of xy is basically the product of xy. So we have this. Recall that if random variable xy are independent, that means their joint distribution can be written as product of each marginal distribution. So this pxy can be split into px and py. What's next? This summation sign has two indexes, x and y. We can split this into x and then into y. And then we just group term with x and we group the other term with the terms only on y. Then we get this. Notice that this bracket is exactly the definition of expected value of x, and this bracket is the expected value of y. So we have this thing. So we have proved that if xy are random variables that are independent, then expected value of the product is the product of the expected value. We can generalize. If x1, x2 up to xn are all independent, then their product is the product of the expected value. If xy are not independent, then we need to compute the expected value using the definition.